can see that it's no longer flat. On the cyclohexane are basically totally tetrahedral. And you could look at our least strain of the rings because to get, so in cyclohexanes we talked about how to draw these, draw a second set and then connect them, and the key thing in 3D. So what we're essentially starting off with, from your perspective, yes. So this is, I can change my perspective even more. So the key with the visualize and like feel, cyclohexane chair are sticking up and sticking down. So we are actually aligned with one another. It goes to sort of the concept of a chair flip. So or a chair flip or a ring flip, let me change my perspective for this so that, all that's happening is that you're rotating such that, come on, heel down. The other end of the ring switches.
Electron movements is like on.
Right, so the flat cycle is a flat representation of this. Hexagon, right there, that's equivalent something like this. Up, and I draw the seal on. Okay? So let's look at all that I have done is rotate all of the carbon-carbon bonds in my. If we look at it through.
Oh wow.
To form those two tails like that.
Exactly. So yes. So that brings us to this.
Hey, can you shut up?
Both of those different chair conformations. So not a massive difference, but enough to cause a change in 1, 2, 3. They are 3 atoms, this carbon 2, and this carbon 3, and this back carbon. We'll see that our methyl group, that's not at all what this is saying. It's saying that about Newton projections and how where they're not so far. So this ends of these different groups. So if I complete the electron cloud of my hydrogen and my methyl group, they're overlapping with each other and bumping into each other, and that's why we sort of show that. Any other questions on this one?
I'm actually a salmon.
So for 2 kilojoules, that interaction goes up in energy. Go from 2 kilojoules to 4 kilojoules. What does that mean in terms of what our objective reality of how these rings sit on? And what it means is that we go from a 70-30